question 1, and this is the first equation.
How do I write that into factored form?
Well, first you have to find its factor. So you're going to take this number and multiply it by that number, which will give us x squared plus 7x minus 18. And then we would take this number and find the factors that will go into it to get that will still equal out to this number. And that paper, sorry, I saw that, is x plus 9x minus 2. And you divide both of these by 3 because you have to put this number back in. And this one will give you x plus 3. And this one will give you that same number. So you slide this number up here, so it will be 3x minus 2. And your factors are 3, so negative 3, and 2. 2 friends.
How can I verify my solution?
Put it in your calculator. As you can see, those are their numbers. That's our table, so they match exactly. And if you go to the graph, they match up perfectly there too. It is between the solutions, which is this. Well, actually, it's that pretty much. And the graph, well, the solutions are where it hits 0 on the x-axis. I don't want to ruin Drew's pretty graph, which is why I was yelling at him to stay up here so we could look at the calculator. No. You can do the walk of shame back up here. As you can see that's where they're crossing 0. And it's going to use this for the go. And the reason why we write it in factored form is to find these solutions, because that way we know where it hits 0.
Welcome to question 2. Instead of getting one equation, we get 3, and we're going to get different information from each one.
How long was the rocket in the air, and which form of the function would you use?
We would use this last form because you get the x-intercepts, and as you know, the x-intercept is always going to be time. So you can use this number over here with the crazy x rule to see that how long it was in the air would be 7.623 seconds.
How tall was the roof, and which form of the function would you use?
So, we didn't launch it from the ground, so we launched it from the roof, so it wouldn't be 0. So we need to find how high up it was when we launched it. Because this equation, we couldn't really find a title for it, but it would be this value right here, which would be 15. So it would be 15 units off the ground when it was launched.
How high did the rocket fly? Explain which form of the function would you use and why.
See, because this is the vertex, that would mean that was when it was at its highest point. So you take this value right here, would be how high it ended up going before it started coming down. So it would end up being 240 units.
What was the velocity of the rocket? Explain which form of the function you used and why.
Right. Because we've already used these two, well, we've got apart from this, but we're still going to use this one. This would be the acceleration. So this one would end up being the velocity. So the velocity of the bottle rocket would end up being 120 t.
How tall was the roof, and which form of the function would you use?
Another way to... Again, and you see that's